We have around, I think, 15 lectures and 45 hours in total. So we have to, the syllabus is really big and it's not that easy. So you have to, we have to conduct the lectures more than 45 hours, I think. And I want you to take notes. Although I'm using a PowerPoint presentation, I want you to write the notes. I'll give you the notes because previous pages also I did the same thing. Otherwise, you people will find the final exam really difficult. Okay. So if you don't have notes to refer, then it's going to be a really difficult subject. It won't be difficult if you take the notes and if you attend the lectures regularly, because I don't think it will be a problem because everyone is attending using Zoom, right? Nowadays. So everybody should attend. And I have to tell you a few more things. Okay, anyone who doesn't understand Sinhala? Anyone who is Tamil or who speaks in any other language other than, okay, then I'll only speak in English. But for further clarifications, if you guys want to make like if you guys want me to speak in Sinhala, you can tell me. Okay, if you didn't understand a complex concept, otherwise I'll speak in English. Okay. So let's mark the attendance first, and 80% attendance have to be maintained to be eligible to sit for the exam. Okay, I'll explain you the details later. Slides are visible. Okay, so okay, so the module name is wireless communication. Okay. Any issue? You guys have any issues? මොනවාරි ප්‍රශ්න තියෙනවා නම් මේ මෙතන chat එකෙන් මට කියන්න. හරිද? Okay, let's start the lecture. And I want you to participate for the lecture with me, okay? Otherwise, it's going to be really difficult. I can't just speak from this end and I'm not even sure whether you guys are listening or not. So if I ask a question, I want to turn the microphones on and reply, okay? I want to talk. Dilshan, you can mute your microphone. Okay, so let's start it off. So the module name is wireless communication. And do you guys have any idea of what wireless communication is? Can you give me a few examples that you see in day-to-day life? You can use the chat room if you want. If you don't want to speak up, you can type it in the chat and answer me in however the way you like. Okay, what are the applications that you see wireless communication in day-to-day life? As like we use a lot of devices, right, to communicate with different devices or different people. So tell me a few examples that you see in day-to-day life where wireless communication technology is used. Anyone? Okay, Bluetooth. And anybody else? Wi-Fi. Okay. Wi-Fi router. And the most commonly used device that we all have in our hands is the mobile phone. Okay. So in this module, what we are going to do is we are going to understand the basics of this wireless communication. Okay. basics, the theoretical aspects of the wireless communication, then applications, different technologies, different wireless standards that we use. So standards like GSM, GPRS, you have heard about the different generations of mobile communication, right? So these concepts are really interesting because we are basically the half of the syllabus is about mobile communication and cellular communication. Okay, half of the syllabus. So we will get to know each and everything, or most of the basics will be covered in this module. Okay, then you will have a broader understanding of what mobile communication is, and also the numerical calculations associated with the module, with mobile communication systems. And you will be surprised as to how interesting this field gets when you continue with the lectures. Okay, and then first of all we need to know about this module and the marking criteria of the module. So you will have 2 continuous assessments. Okay, from each assessment you will get 40% contribution to the final marks. Okay, so you will have 2 continuous assessments, and you have to pass the assessments, and you have to get marks greater than 30. Okay, in each assessment the marks will be given out of 30, but the overall marks have to be greater than 30, greater than, yes, 30 to contribute for the final exam. Okay, then final exam is 3 hours. It's a written paper, and 60% will be calculated for the final result. And I will conduct tutorials, a few tutorials, 2 to 3 tutorials to cover the all mathematical calculation based questions. And tutorial marks, you will not be given any marks in the tutorials, but tutorials you have to attend, and they are mandatory because otherwise you will not be able to perform in the final exam. This module is not that difficult if you do it right. Okay, you have to write the notes, you have to take the notes. Everybody should have a book, because last semester I have done, and from them I have learned a lot of things. Because if you don't take the notes, many people, they come to the class with just a piece of paper, they scribble something in the paper, and they take it home and they don't continue writing any notes. Okay, you can't do that, because for your own good I'm telling you. Can we do more continuous? Okay, are you asking me to conduct more than 2 continuous assessments? Is that what you're asking?
Yes, madam.
Okay, I'll discuss it with Mrs. Malwatta and I'll let you know. Okay.
Okay, madam.
Okay, so but you have to be present. Okay, I might be able to conduct more than 2. Let's conduct 3 then. Okay, I'll ask Mrs. Malwatta and let you know. And then, okay, other than that, attendance is mandatory. You have to attend for more than, because I think 5 to 6 people couldn't sit for the exam last semester because they didn't attend. Their attendance is like a 60%, 70%, 75%, even saying 79% is not allowed. It's a strict criteria. I was not allowed to let you sit in the exam. I can't control that. It's controlled by the administration, so you definitely have to attend. Okay. So if we have, for example, 15 lectures in total, you have to attend for at least 12. Okay. Then the total number of hours, like I said, is 45. It can vary because every day we have 3-hour lectures now, because last semester we had, I think, from 8:30 to 12, I think. Yes, from 12:30, yes. So we had 4-hour lectures, and I can't remember the exact number of days we did the lectures, but yes, 45 hours is not enough, so it can definitely vary. Yes, this is the overall evaluation of this module. Okay, and else? Okay, so when I'm teaching, if you find any issue with me teaching, if you don't understand anything, or if I'm doing it too fast or too slow, you can please speak up. Okay, since I don't see you guys, I can't see you, and I can't let you switch on the videos because the, we can't get stuck in the middle of the lecture. So I want you to speak up if you have any kind of issue. You have the chat room. If you are not willing to switch on your microphones and talk with me, you can chat and you can let me know any issue. Okay, if you didn't understand anything, then you have to tell me. Okay, there are 18 participants. Navindu Prakash. Navindu Prakash. He joined just now, right? I didn't mark his attendance, did I? Navindu Prakash. Navindu Prakash, can you tell me your registration number? Can you tell me your registration number? Oh, he is. All right. So, can you guys let him know? Okay. Okay. So, this is the overview of the module. Like I said, we are more focusing. More than half of the module is focusing on cellular communication, mobile communication. Okay, more than half of the module. Then power calculations. I hope you guys know about decibel calculations in A levels. Yes, in A levels. Okay, decibel calculations. But I'm not assuming that you know or you remember everything. I'll start from the beginning, and you have to practice a lot in decibel calculations. Okay, but don't worry, it will be easy at the end. I'll give you I'll teach you the tricks, I'll teach you the ways and methods. So at the end, it will be difficult, it won't be difficult, because for the last semester students also, initially they found it really difficult. The overall module, they found it difficult, but it didn't. At the end, they have done well in the final exams, most of them. Okay, because I tried a lot and they also tried a lot from their side. So I want you also to do the same thing. So power calculations, it won't be difficult. I'll be revising throughout the module. If you find anything difficult, if you don't understand anything, only issue I find here is Zoom is okay with me, but since I'm not able to write properly in the board and illustrate the things properly, it is a bit of a challenge. Okay, that's the only challenge I find over here. Otherwise, it's fine. Then we do radio wave propagation, different modulation techniques. You must have heard or might have not heard. It's okay. We'll go in deep in different modulation techniques. Then multiple access technologies and other wireless technologies, not only the mobile communication. We have Wi-Fi, WiMAX, Zigbee, satellite communication, Bluetooth. I'll introduce a few things over these on these technologies, and also about wireless standards like GSM, GPRS. Okay, so this is the reference book we are using. We are using for this module. That is the Introduction to Wireless Communication Systems by T. Rappaport. Okay, if you want, I can share you the PDF, or you can find it online. All right, it's a bit of a old book. It was written in, I think, I can't remember the year, but it's a bit old. You will find it a bit difficult to understand, but there are a lot of other simpler versions for wireless communication systems. Any book you can prefer, it doesn't matter. But the material I'm taking is from T. Rappaport's book. Okay. So if you want any other simpler versions, or if you want any other, like, if you really want to refer to a good reference book, I can search online and I can issue you one. Okay, if you want. Okay, let's move on to the next slide. Okay, today's lecture, I'm doing an introductory lecture, but we have 3 hours left. So we'll have to, I'll do the introduction. Then we need to know about electromagnetic waves. I know you have heard about these things before, but I also know that you don't remember anything. Okay, so I'm going to refresh the things you have learned in A levels and during your studies. Then we'll do about radio band and radio communication systems, the radio link architecture. I want you to write things down. Okay, even if you have a book today, if you don't have a book today, write it in a piece of paper, but please buy a book and start writing. Okay, I'm not going to pinpoint each every one of you to show me the books whether you are taking the notes or not, but I will give you the notes. Okay, I'm not going to conduct this like a A-level class. I don't really want to do that, but I know that at the end everybody is struggling without the notes. Okay, and the slides also I have, but slides don't say everything you want to know. Okay, if you guys have any issue, tell me right now. If you can't take notes or any issue with taking notes, you can tell me right now. Otherwise, I'll continue. Okay, so what basically is wireless communication? Wireless communication means we can send something from one place to another, sending something, or uh, communication. I am also communicating with you, right? I'm talking and you guys are listening, so that I am the transmitting source. I'm the source, the transmitter, and you guys are the receivers. Okay, so this is a kind of a communication. Uh, so communication means transmitting information or carrying information from one place to another. Okay, that basically is what communication is. So wireless means the medium by which the communication happens is not a physical link or a wire. Okay, it's not a physical link. So you can't find any cable over which you are communicating. Okay. So wireless communication means that we communicate using free space or through air. Okay. Then radio communication means using a specific frequency to communicate. Radio communication. We use radio frequencies to do this communication. Okay, so everybody knows that waves are used to communicate. Waves contain energies, so energies are propagated using waves. Taranga කියන්නේ. හරිද? Energies are propagated using waves, and waves are used to communicate. Now different waves have different frequencies. Okay, I'll get to that later. I'll explain you what frequencies are first of all. You guys might remember, you might not remember, it's okay. Okay, so frequencies are there, so over different frequencies we communicate with each other. So I am communicating with you, and right now I am talking at a different with a certain frequency, right? So radio communication means communication using radio frequencies. Okay, I'll introduce you what radio frequencies are later on. Now, like you said, these are the examples, a few examples of wireless communication systems. So we have remote controllers for TVs, for ACs. We have remote controllers. Then we have cordless phones, telephones. Okay. Then walkie-talkies, mobile phones. Likewise, there are today's world. We have a lot of applications with this wireless communication. Okay, so can you guys start writing? I'll give you the notes. Okay, you can write. Anybody find any issue in writing today? Can you tell me? Or otherwise, can you confirm me that it's okay? You can take the notes. කාට හරි notes ලියා ගන්න බැරි තැනක ඉන්නවා නම් හරි එම් මොකක්ද ප්‍රශ්නයක් තියෙනවා කියන්න බෑ. No one has an issue? I think a few people have some network issues, right? It's okay, I'll share the presentation. Okay, so can you take these notes, take these things down, write these things? Introduction to wireless communication. Introduction to wireless communication. Write down wireless communication is a method of transmitting information wireless communication is a method of transmitting information from one place to another without using any connection links. Without using any physical links. Without using any physical links. Like wires or cables. Done? Okay. So then let's move on to the next slide. Now we have different network types based on the distance. This is also a thing that you need to understand first. Okay. What is the long form of PAN? PAN is personal area network. Okay. We have different types of personal area networks. Personal area networks usually reside in areas which are less than 10 meters uh, of distance. Okay, so now we have Bluetooth, ultra wideband, Zigbee. These technologies are personal area networks. Now Zigbee, Bluetooth, we will study about them later on, okay, in detail. Then we have land area networks where the distances are up to 150 meters. Land area networks are they have data rates like up to 11 to 54 Mbps. We all know that. Now tell me a commonly used land area network. If you guys know, tell me a commonly used land area network we use in day-to-day life. Can you tell me that? You have to answer me. You can type your answers and tell me. Most commonly used land area network in day-to-day life. Anyone? It's already written in the slide. Hyperland 2, 802.11. Any commonly used one? Yes, Wi-Fi. Okay. Now, yes, Wi-Fi or connecting with the Wi-Fi router. Wi-Fi is a land area network. Now, 802.11 APEG. 802.11 is the wireless standard. Okay, the telecommunication standard. Now we have different telecommunication standards for different wireless technologies. All right. Now, personal area networks like Bluetooth is 802.15.1. Okay. These things you usually remember. You have to remember. Okay. Because these are very important when you go out there in the industry and you start working as a technician or an engineer or anybody. Okay, so you need to definitely remember the wireless standards for different technologies. Like Bluetooth is 15.1. Now these standards are set by an organization known as IEEE. If you guys know the long form of IEEE, what is the long form of IEEE? Have you heard about IEEE? Yes or no? IEEE. Have you heard about IEEE? IEEE. I E. Yes. Okay. So IEEE means Institute of Electrical and Electronic Engineers. Okay. Now all these things have IEEE standards. This is the IEEE standard for Bluetooth, and this is the IEEE standard for Wi-Fi. Okay. And then we have different data rates. Now data rates are given by Mbps, megabits per second. Okay. These are the data rates. Then the other one is the metropolitan area network. Okay. Metropolitan area networks go up to 5 kilometers. Then we have wide area networks. Wide area network architectures are GSM, GPRS. These are used in mobile communication. Okay. Different generations of mobile communication. And this wireless standard is 802.2. Okay. Then we have regional area networks. So these are the types of networks, that wireless networks that we use every day. Okay. And they are based on the distance. This categorization of network types are based on the distance. Okay. Now let's move on to the next one. Introduction to waves. Now, what do you guys know about waves? What are waves? Waves are, now I'm not giving you the note for this. Okay. Okay, regional area networks. Regional area networks are like this satellite communication. Okay. Regional area networks are satellite communication and networks which are more than 100 kilometers wide. Okay. Now satellite communication and other business networks, they can be um, they can be they can span in a space more than 100 kilometers wide. Okay, more than 100 kilometers means uh, connecting different areas in a country, different geographical areas in a country, or even different continents. Now satellite communication is a good example for that. Okay, by satellite communication we can connect to very different geographical areas, so different countries even. Okay. Now, fiber optic cables are fiber optics and copper wires, coaxial cables. They use physical media to connect. Okay, physical media to communicate. But we are not talking about them. We are talking about wireless communication technologies. All right. Okay. Then we have the waves. Waves are what? Waves are basically used to transmit energies from one place to another. Waves are used to transmit energies from one place to another. Now, how that can be realized? Okay. Now when it comes to waves, we need to know what the wavelength is, the amplitude is, and where the waves propagate. It's very important. Okay. Now amplitude of a wave is the um, the distance between this reference line in the x-axis. You can see the distance from this reference line to the highest peak of the wave. Okay, that is the amplitude. Anybody has a issue, a question? කාට හරි ප්‍රශ්නයක් තියෙනවද? Dilshan, your microphone is on. Okay. So waves, the amplitude of a wave. I assume that you guys already know this. Okay. This distance is the amplitude. Okay. And this distance is the wavelength. Okay. And you can also mark wavelength from here to here. Okay. Now, if the x-axis had time, this one is the variation of the amplitude of a wave with propagating distance. Okay. මේ දුරත් එක්ක වෙනස් වීම තමයි මේ තියෙන්නේ. එතකොට දුරත් එක්ක වෙනස් වීමේදී අපි මේ points දෙක අතර දුර ගන්න wavelength එකක් විදිහට. Okay. When the variation is along the distance of propagation, then this difference is a wavelength. Okay. But when the variation is with time, okay, when the amplitude varies with time, then the difference of one cycle is a period. Okay. This is not a wavelength. That is the most important thing you need to understand first. Maybe you guys already know that, or you might not know. Okay. Period means one cycle of a wave when it is varying with time. Okay. Wavelength is one cycle of a wave when it is varying with direction or distance. Okay. And these are the two main things you need to understand. Okay. Now, this is the equation to calculate the frequency. Frequency of a certain wave is given by the number of cycles it completes in 1 second. Okay, number of complete cycles like this, number of periods it can complete in 1 second, that is known as the frequency. Frequency is measured in hertz, or in SI units you can write it as per second, number of cycles per second. Okay, so frequency of a wave is like that. Then this is the main or the most famous equation for the speed of a wave propagation. That is V equals F lambda. You guys know that. You have done it in A levels. Frequency is calculated in hertz. Okay. Frequency is calculated in hertz. Hertz. It's said. Hertz, and lambda is in meters. Then speed is given by meters per second. Okay. What is the speed of light? What is the speed of light? Yeah, 3 into 10 to the power 8. Okay. So speed of light is 3 into 10 to the power 8. And you guys know that speed of light is normally noted by c. Okay. Now these are the basics. Do you want to take the notes for the waves, introduction to waves? If you guys know, it's okay, then I can move on to the next slide. Do you want to take the notes, or is this enough? I think this is enough. This is a good explanation. So the only thing you have to understand is that if x-axis is distance, okay, this is the most important thing. If x-axis is distance, then you can mark the wavelength. You know, in some papers, some marking, when I mark the papers and when I mark the assignments, when I ask to mark the wavelength of a wave, they mark time over here and wavelength like this, and it's completely wrong. Okay, wavelength has to be marked if the x-axis represent the distance. Okay, if the x-axis is time, then this is okay. I'll give you a small note. All right, now write down introduction to waves. Introduction to waves. First of all, we'll write what basically a wave is. Okay, now write down a wave is a wave is wave is a disturbance. Disturbance means a variation. Okay, wave is a disturbance. Disturbance. Wave is a disturbance that moves energy from one place to another. Wave is a disturbance that moves energy from one place to another. Okay, and then write down the wave propagates in a medium. The wave propagates in a medium. Now, the another thing you need to understand is not a matters are not transferred from one place to another. Okay, මෙතන වෙන මොකුත් physical දෙයක් එක තැනකින් තව තැනකට ගෙනියන්නේ නැහැ. එනර්ජි එකක් මාරු වෙන එක විතරයි වෙන්නේ. ෆිසිකල් දේවල් එහෙමම තියෙනවා. Physical things means that if we take an example of a sound wave, okay, we have air as the medium. Now air has what are the physical things that we have in air? Air has air particles, right? Air molecules. Okay, now these are like small particles in air. Okay, so when we transfer, when a sound wave is transferred from one place to another, what happens is that these particles, um, whatever we are speaking, we emit a certain energy. Okay, we transfer a certain energy to the medium. The medium is air. Now air has a lot of particles. Now these particles don't move from this place to another. Okay, if there are particles over here, now I am speaking from here. Okay, and the receiver is over here. Okay, and these are the different particles of air in the medium. Okay, now this particle, if we take this particle and I'm talking, and if you take this particle does not move from here to here. තේරුණාද? මේ particle එක මෙතෙන්ට යන්නේ නැහැ. This matter does not move. This particle does not move from here to here. But somehow the energy that I transmit is moved from here to here. Okay, if this is the transmitter and if this is the receiver. Energy is transmitted. How? by the contraction and expansion of these particles. මේ particles වල vibration එකක් ඇති වෙනවා. By absorbing the energy I am transmitting, the particles are vibrated. Okay, they vibrate, they will contract and expand. මෙතන පොඩි oscillation එකක් ඇති වෙනවා. පොඩි replacement, there is a small replacement. Okay, displacement. මේ particles පොඩ්ඩක් මෙහෙට vibrate වෙනවා. මෙතන මෙහෙම vibrate වෙනවා. vibrate වෙලා මෙතන තියෙන energy එක මෙතෙන්ට transfer කරනවා. ඊට පස්සේ මේව vibrate වෙනවා. Okay, these vibrate, then the energy is transferred over here and these particles vibrate. Likewise, the wave will transmit the energy I am transmitting from here to here without physically moving this particle from here to here. තේරුණාද? The matter is not moved, only the energy is transferred. Now, during this transfer, we can have contractions. ඒ කියන්නේ එකට එකතු වෙනවා particles, I expand වෙනවා. එකට එකතු වෙනවා, expand වෙනවා. Now, that way, the contraction points can be drawn like this, and expanding points can be drawn like this. Contraction points are drawn like this, expanding points can be drawn like this. හරිද? එතකොට මේ එකතු වෙන එකට එකතු වෙන හරියට අපිට මෙහෙම අඳින්න පුළුවන්. මෙහෙම අඳින්න පුළුවන් expand වෙන හරිය. එකතු වෙන හරිය මෙහෙම ඇඳලා expand වෙන හරිය මෙහෙම අඳිනවා. එතකොට axis එක මේ තියෙන්නේ amplitude එක. මේ vary වෙන්නේ මොකද්ද? Distance or the time. Okay, so this can be distance or time. හරිද? එතකොට එක වෙලාවක එකයි තියෙන්න පුළුවන්. It can either be distance or time. කාලයත් සමග දුරත් සමග මේ particles වල variation එක. particles එකතු වෙනවද ළඟ. This is an example of a sound wave. Okay, audio wave. This is an example of audio wave and how a audio wave is transferred from one place to another through air. Now you guys understand what waves are and how waves are represented this way. Okay, so I gave you the note. Now waves transfer energy from one place to another, and waves are used to waves are used to transmit different types of energies. Okay, now write down, there are different types of waves. There are different types of waves which transmit. There are different types of waves which transmit different types of energies. Okay, there are different types of waves which transmit different types of energies. For example, there are sound waves. There are sound waves, electrical waves, electromagnetic waves, which transfer audio, electrical energy, or electromagnetic energy from one place to another. From one place to another. Then write down the frequency of a wave. Frequency. Frequency of a wave frequency is the number of cycles of a wave. Frequency is the number of cycles of a wave that pass a fixed point. Frequency is the number of cycles of a wave that pass a fixed point in a given amount of time. Given amount of time. The measuring unit is hertz. Hertz, H-E-R-T-Z. H-E-R-T-Z. Hertz. Or in short, we can write capital H, simple Z. And write the formula for frequency to calculate the frequency. Okay. F equals 1 by T, and write T as the period. Period. T is the period. Okay. Okay. Then the speed of a wave. The speed of a wave can be written as V equals F lambda can be written as V equals F lambda, where F is the frequency and lambda is the wavelength. F is the frequency and lambda is the wavelength. Okay. Okay, let's move on to the next one. And please, you can draw this later on, or I'll share the slides with you. You can draw this later on and you can complete the notes because this is important. Okay. When you mark, when you draw something, you definitely have to mark the axis. Okay. And this axis is power. Usually power. Okay. Power. Or it can be anything. It can be a voltage. Okay. It can be power or anything. Okay. Any quantity. Mostly power. We use mostly power in watts. Okay. In y-axis. And the x-axis is the most important thing. You have to mark it in distance or whether it is a time. Now, if I ask you to draw mark the period of a wave, then definitely I'm looking at the x-axis, and if it is not time, then it's not correct. Okay. Okay. Then the next slide. If you find any difficulty in understanding these things, I think these are really very simple concepts. And I think everybody has gone through these in A levels. Electromagnetic waves. What are electromagnetic waves? Now, electromagnetic waves means the electric field of the wave is marked in red and the magnetic field of the wave marked in blue. They oscillate perpendicular to each other and propagate in a perpendicular direction to both of these waves. Okay. Now that means electric field. When we take the electric field, this is the if this is the y-axis, this is the x-axis, this is the z-axis. We always work in 3D planes, right? So this is the y-axis, x-axis, and this wave is propagating like this. Okay, and the magnetic field is oscillating perpendicular to the electric field. Okay, now these two are perpendicular. This is a perpendicular, this is perpendicular. Okay, these two are perpendicular, orthogonal to each other. We call it as orthogonal. Okay, now electric field is oscillating in xy plane, magnetic field is oscillating in xz plane, and they are orthogonal to each other. And both of these oscillating fields are propagating in orthogonal direction to both of these oscillating fields. Okay, now x direction is orthogonal to y and z. Okay, this oscillates in this direction, this oscillates in an orthogonal direction like this, and they both propagate in x direction of propagation. Okay, now write down the note for electromagnetic waves. Direction of propagation. Write down electromagnetic waves have electromagnetic waves have electromagnetic waves have an electric field and electromagnetic waves have an electric field and a magnetic field oscillating perpendicular to each other. And the direction of propagation is perpendicular to both of these oscillating planes. The direction of propagation is perpendicular to both of these oscillating planes. Okay, and you can refer to the figure over here. Okay, let's move on to the next one. Okay, then you need to know what a frequency spectrum is. You might have heard this before or not, but it's very important. This is a term. Spectrum is a term that is used in many occasions in wireless communication. Not only in wireless communication, in optical fiber communication, anywhere. Okay, you have not heard about the word. Okay, spectrum, frequency spectrum. It's very important. Spectrum means a frequency spectrum means okay. When we are generally speaking, spectrum means a collection of something. Okay, spectrum is a collection of something. Now, frequency spectrum is a collection of many frequencies. It's as simple as that. Collection of many frequency components. Now, for example, a simulation over here is in MATLAB. You can see that this is the power. And can you guys tell me how many frequency components are there in this example? Number A, A. In figure A, can you tell me how many frequency components are available? Can you look at the figure and tell me how many frequency components are available? නිකම් බලලා කියන්න බලන්න මේ figure A එකේ frequencies කීයක් තියෙනවද? X axis එක බලන්න, Y axis එක බලන්න. Okay? Okay, I'll tell you in Sinhala after. Yeah, I'll tell it later. Okay? Then මෙතන මේ චූටි මේ නිකන් noise වගේ තියෙනවා හිතන්න නැතුව. හරිද? Ignore these small oscillations or variations or small noise components. After ignoring these ones, tell me how many frequency components are there. Not 100. Okay, how many frequency components are there? Yes, there are 4 major frequency components. Okay, one is at, let's say, 15 hertz. Okay, one is at 15, one is at 40, other one is at 60, and this one is at what? 85. Okay, and of course you have to mark the axis units in hertz, and power is in let's say in milliwatts. Okay, all right. Now there are 4 frequency components, more than one, right? And we have a collection of 4 frequency components, and this is termed as a frequency spectrum. Okay, frequency spectrum. So what is the amplitude of first one? At 15 hertz, it is 300 milliwatts. Milliwatt 300 amplitude එකක් තියෙන. හරිද? 40 watts, sorry, 40 hertz frequency component එකේ 750ක milliwatt amplitude එකක් තියෙන. Okay, and this one also has 750, 60 hertz, and 85 hertz has 300. හරිද? මේ frequency spectrum එක amplitude එකයි frequency එකයි තමයි බලන්නේ හැමතිස්සෙම. Y axis එකේ තියෙන amplitude එක, X axis එකේ තියෙන frequency. මොන frequency component එක කොච්චර තීව්‍රව තියෙනවද කියන එක තමයි frequency spectrum එකකින් පෙන්නන්නේ අපිට. තේරුණාද? ඒ වගේම collection of frequency components. ඒ collection එකේ එක component එක කොච්චර තීව්‍රව තියෙනවද කියන එක තමයි frequency spectrum එකකින් පෙන්නන්නේ. හරිද? තේරුණාද? It's not that difficult. Okay, these words sound scary, but they are not difficult to understand. But you need to know the basics. Basics තනං ඉන්න ඕන හැම දෙයකදී. හරිද? මේවා තේරුම් ගන්න එච්චර අමාරු නෑ. මේවා හරිම lazy concepts. එතකොට දැන් අපි හිතමුකෝ දැන් ඔන්න අපි කමියුනිකේට් කරනවා කියලා. දැන් මම කතා කරන සවුන්ඩ් එකම බලන්න. ඒ සවුන්ඩ් එකේ variations තියෙනවා. හරිද? මේ සවුන්ඩ් එකේ frequencies වෙනස් වෙන්න පුළුවන් වරින් වර. හරිද? දැන් මේක මෙන්න මෙහෙම plot කරොත්, මේ වගේ plot එකක් ගත්තොත් මේකේ තියෙන frequency components කීයක්ද? Infinite number of frequency components. You can see from 0 to 40 hertz. ඇත්තටම දැන් ළමයි දැන් මෙහෙම ගත්තොත් අපි මේ line එක ගත්තොත්, when I draw a line like this, okay, how many points are there in this line? මේ line එක ඇතුලේ points කීයක් තියෙනවද කියන්න බලන්න. I drew a line like this, and tell me how many points are there. මේ line එකේ points කීයක් තියෙනවද? points කීයක් තියෙනවද? No, not 2. This line has how many number of points? මේ දැන් මෙහෙමනේ අපි line මොකක් හරි line එකක් අඳිනවා කියන්නේ මෙන්න මෙහෙම dot කිහිපයක් connect කරන එකනේ නේද? මේක තව zoom කරලා බලුවොත් ඇතුලේ මේ වගේ dots නේ තියෙන්නේ නේද connect වෙලා. ඈ මේ dots එක ළඟ වැටෙන්න line එකක් නිර්මාණය වෙනවා මේ විදියට. Okay. Now tell me how many number of dots are there in this line? Yes, you can't count. There are infinite number of dots. තේරුණාද? මෙතන තියෙනවා අනන්තයක් dots. Yes, infinity, infinite number of dots in this line. So likewise, now I am connecting this. මේ මෙහෙම frequency ටික මම connect කරලා තියෙනවා. connect කරලානේ තියෙන්නේ. ඒ කියන්නේ මේ හැම තැනම 5 වල විතරක් නෙමෙයි 5.0001 0002 likewise. Okay, මෙහෙම frequencies ගොඩාක් තියෙනවා. තේරුණාද? We have how many frequency components in total? Infinite number of frequencies. Okay, we have infinite number of frequencies in this spectrum. But they span from which place, which frequency to the which one? කීයේ ඉඳන් කීයටද මේ frequency components ගොඩ හැදිලා තියෙන්නේ? 0 to okay 40. 0 hertz වල ඉඳන් 40 hertz වෙනකන් components කීයක් තියෙනවද? infinite ගාණක් මෙතන තියෙනවා. Okay, from 0 hertz to 40 hertz 0 ඉඳන් 40 වෙනකන් විතරයි values තියෙන්නේ. නමුත් ඒ අතර the frequency components infinite ගාණක් තියෙනවා. හරිද? And this collection of frequency components is known as a frequency spectrum. තේරුණාද? Okay. Now the amplitude is measured here in decibels. Decibels is a unit, a log scale representation of power. හරිද? decibel කියන්නේ log වල දාලා ඇයි අපි log වල දාන්නේ මොනවා හරි? log වලින් ලඝු කරනවා කියන එකේ තේරුම මොකද්ද? ලඝු ගණක එක තේරුම මොකද්ද? logarithms වල තේරුම මොකද්ද? Why do we take logarithms of a certain number? Why do we take? What's the meaning behind a logarithm? These are the simple things. You know, when somebody teach you something, you always have to question. Okay, that's the most important thing you have to learn. When somebody teaches you something, if you don't understand, you definitely have to ask. Logarithm means ලඝු ගණක කියලා අපි නිකන් කටපාඩමින් O level වල ඉගෙන ගත්තා, A level වල ඉගෙන ගත්තා. තේරුමක් නැහැ. ඒක කාලයක් යනකොට අමතක වෙනවා. ඒක තමයි මිනිසුන්ගේ හැටි. හැබැයි ඒකේ තේරුම හරියට තේරුම් අරගෙන තිබ්බනම් ඒ කාලේ මේ වෙද්දි අමතක වෙන්නේ නැහැ, because it's a very simple concept. Because you make it complex, you forget it after a few months. Okay, so logarithms are used to shorten the things. හරිද? දැන් මේ ස්කේල් එක ගත්තාම මේ බලන්න මේ ස්කේල් එක 100 ඉඳන් 800 වෙනකන් තියෙනවනේ මෙතන. හරිද? මේ this scale varies from 100 to 800. But when you put in logarithms, when you take the log value of this 100, okay, to the base 10, when you take, this is a මේක මේ extra එකක් මම මේ කියන්නේ. හැබැයි මේක ඉස්සරහදී ඔයගලන්ට ඕන වෙනවා. log base 10 100 කියන්නේ කීයද? දන්න කවුරු හරි ඉන්නවනම් කියන්න බලන්න. log base 10 100 කියලා අපි කිව්වහම මේක කීයද කියලා නිකමට හරි තේරෙන කවුරු හරි මතක කවුරු හරි ඉන්නවනම් කියන්න. මේක බය වෙන්න දෙයක් නැහැ. මම ඉස්සරහදී කියලා දෙනවා. හරිද? This is 2. Okay, good. This is 2. Okay, 2 means that මෙතන මේ 100 වල තියෙන එක වෙනුවට අපිට දාන්නේ 2. හරි? එතකොට මේක ලඝු කරනවා කියලා සිංහල වචනේ තේරුම මොකද්ද? ලඝු කරනවා කියන්නේ කෙටි කරනවා කියන එක. එතකොට මොකක් හරි ස්කේල් එකක් ලොකු නම්බර්ස් වලින් තියෙනවා නම් මේ 800 වගේ දෙයක් ඒක පොඩි නම්බර් එකක්. නමුත් අපි හිතමු 10 to the power 8 9 10 ඔය වගේ නම්බර්ස් වලින් තියෙනකොට අපි ඔක කොට කළා ස්කේල් එකකට දාන්න ඕනේ නම් අපි පාවිච්චි කරනවා මොකද්ද? logarithms. Okay, so logarithms are used to shorten. It's a short representation of a certain value, shortened representation of a certain value. Okay, so that's why we use logarithms. So amplitude is written in decibels here, given in decibels. You can also write it in power, milliwatts or watts. You have a certain formula. By using that formula, you can convert this decibel value to a watt value. Okay, so this is also an example of a frequency spectrum. This is also an example of a frequency spectrum, figure A and figure B both. Okay, now here we have 23.87 hertz. මෙන්න මේ 23.87 මෙතන නම් තියෙන්නේ ඒකට අදාළ ඇම්ප්ලිටියුඩ් එක මෙතනින් දෙනවා. තේරුණාද? This is 0 decibels. 0 decibels means there is a certain amplitude. Watt වලින් යම්කිසි value එකක් තියෙනවා. නමුත් decibel scale එකේදී ඒක 0. තේරුණාද? Okay. So okay, so what else? And now the frequency spectrum, you can write down a short note on a frequency spectrum. Write the topic, what is a frequency spectrum? What is a frequency spectrum? Okay, write down a frequency spectrum of any signal or of any signal. It can be an electrical signal, it can be a optical signal, it can be a sound wave. Okay, it contains different frequencies. All right, and the plotting of that frequencies against power is called the frequency spectrum. Okay, so the frequency spectrum of any signal is the representation of frequency spectrum of any signal is the representation of the distribution of amplitudes, the distribution of amplitudes frequency representation, sorry, frequency spectrum of any signal is the representation of distribution of amplitudes of different frequency components. Distribution of amplitudes of different frequency components. Okay, then write down simply frequency spectrum is a collection of multiple frequency components, multiple frequency components with their amplitudes represented with their amplitudes represent. Okay, so this is the basic idea of a frequency spectrum. Okay. All right. Let's move on to the next slide. And if you didn't understand anything in this slide, you can ask me. Right. තේරුම් නැති යමක් තියෙනවා නම් දැන් අහන්න. තේරුම් නැති මොනවා හරි තියෙනවා නම් දැන් අහන්න. Okay, then I'll move on to the next one. Okay. Okay, what is the electromagnetic spectrum? Electromagnetic wave එකක් කියන්නේ මොකද්ද? Electromagnetic wave is a wave where electric and magnetic fields are oscillating in an orthogonal way. Okay, they are oscillating perpendicular to each other and they are propagating in a perpendicular direction. හරිද? ඒ wave එකක spectrum එක තමයි අපි දැන් බලන්නේ. Spectrum means the collection of frequencies. Now, electromagnetic waves have a series of frequencies. Okay, like for example, most of the electromagnetic waves like X-rays, gamma rays, ultraviolet rays, optical signals, visible signal, infrared, radio waves, microwaves, all these waves are electromagnetic waves and they belong in the electromagnetic spectrum. Okay, and the frequencies are like this, the frequencies. And radio waves are used in our wireless communication application. Radio waves තමයි අපි පාවිච්චි කරන්නේ. හරිද? මේ visible light අපි පාවිච්චි කරන අපිට පේන අපේ ඇස් වලට පේන්නේ visible light. Okay, in optical communication, optical fiber communication, we use visible light in this frequency range. And frequency, how do you convert frequency to wavelength? How do you convert frequency to wavelength? Using which formula? How do you convert frequency to wavelength? How do you convert frequency to wavelength? Wavelength V equals f lambda. This is the equation we use to convert frequency to wavelength. Okay, f lambda. So when you take electromagnetic waves, okay, we have a speed and we can take the relationship between f and lambda is f equals v by lambda. So when you know the lambda, you can find f. When you know f, you can find lambda. Okay. Okay, so this is how you represent, you convert wavelength and frequency. Okay, using this formula. Now, in wavelength, they have converted the frequency to wavelength, and wavelength is usually given in meters, so it's different forms like nanometers, millimeters, nanometers. Okay. Frequency is given in hertz, megahertz, gigahertz, terahertz, and so on. Right? Now, the range that is used in our discussion is in this range, 3 kilohertz to 300 gigahertz. Okay. Now, that is the basic of an electromagnetic spectrum. Spectrum is basically what? A collection of frequencies. Okay. Now let's see the reason why we use radio frequencies in wireless communication, because we have a lot of waves over here, right? Like gamma rays, X-rays, ultraviolet rays, optical waves, infrared, radio, microwave, and so on. But why radio? Why radio frequencies out of all these waves in the electromagnetic spectrum? Because radio frequencies, they can propagate through materials. Okay. Now, for example, if your Wi-Fi router is located somewhere in a different place in your home, and you're working from a different other place, okay, it can definitely penetrate through the materials, Wi-Fi signals, okay. The scattering is a bit high. Scattering means the spreading of the waves when they hit on a certain surface. It's a bit high. But radio waves are, when the scattering is high, then it's not a favorable condition. Okay. But for short distance communication, it's okay. It can be used. It's fine. So easy to capture, easy to generate or capture. It's easy to capture, easy to generate. Okay. The safety risk is low. So that way, radio frequencies are used mostly in wireless communication system, and the main reason is that, okay, the main reasons are because because they are easy to use and they have good propagation characteristics. Okay, you can write it down. You can write it down. Radio frequencies are radio frequencies are radio frequencies are mostly used in wireless communication systems. Radio frequencies are mostly used in wireless communication systems because they are easy to use, comma, because they are easy to use, comma, they have good propagation characteristics. They have good propagation characteristics and are relatively safe to use. And are relatively safe to use. Then write down the available bandwidth. Sorry, the available bandwidth or the amount of spectrum available, the available bandwidth or the amount of spectrum available at radio frequencies is relatively small. At radio frequencies is relatively small. Therefore, we have to find different ways. We have to find different ways to increase the efficient usage of this limited spectrum. We have to find ways to increase the efficient usage of this limited spectrum. For example, we can use different modulation techniques. Different modulation techniques. Different modulation techniques to increase the efficiency. Modulation, 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 to increase the efficiency. Now I set a specific name, that is bandwidth. bandwidth කියන්නේ මොකක්ද? අර ස්පෙක්ට්‍රම් කියන එක තේරුම් ගත්තා වගේ bandwidth කියන එකත් තේරුම් ගමු. ඕකේ? හැමතිස්සෙම bandwidth එක මදි කියන මොකද්ද bandwidth කියන්නේ? In a communication system, what is a bandwidth? කවුරු හරි දන්නවනේ කියන්නේ මම. Yes. So it's the data transmission rate. Okay. It's the data transmission rate, the maximum rate of data transmission. Okay. So let's move on to the